the product session with Credmark, the next generation crypto analytics infrastructure. Today with us, we have Paul, who is the CEO of Credmark, as well as Kunlun, who is a quant analyst at Credmark. This session is brought to you by MetricsDAO, a Web3 analytics community. We have thousands of analysts going through our educational programs, attending sessions, and also completing analytics challenges. So do join our Discord server to get involved if you haven't already. Okay, so really excited to be presenting you Credmark today, and we have two wonderful speakers from this company. So I'll just give the mic over to you.
Okay, thank you very much. I'm Paul Murphy. I'm the CEO of Credmark. I'm going to do the least amount of talking because most of the interesting stuff is going to be explained by Kunlun, my coworker. But I do want to set things up. So first of all, as I said, I'm Paul. I mostly create problems in our company. I have a finance background as well, and as an AI background. I've done a bunch of work in speech recognition and NLP, which is one of the reasons I care so much about modeling, which we will be talking about today. And Kunlun, on the other hand, is a problem solver. He has a background in quantitative analytics, and as he says, he discovers order from stochastics. We'll let him tell you all about that in a bit. So you essentially have a yin and yang presentation going on here. So why do we start Credmark? We started Credmark because we originally wanted to be a credit bureau for Ethereum addresses, and in order to do that, we had to build credit models, and discovered how incredibly difficult this was. We had to run our own nodes, we had to build our own ETLs, then we had to extract the data we needed, analyze it, and all of this took forever. And we realized very early on that a lot of people were going to need to do this. And so what we did was we took our early work and we generalized it, and we developed a platform that makes it possible for anybody to do this work, as you'll see, relatively easily. So most of the analytics platforms that are out there are really focused on data engineers, and we certainly believe that data engineers can and should use our platform, because as you'll see, we add another layer of tooling on top of the data and the typical SQL data extraction tools that are available. But because of our backgrounds, we really focus on quants and data scientists who typically are kind of in the middle of this process. So they normally depend on data engineers to get them the data. Then they depend on software engineers to translate their models into something that can be executed. And then they depend on operational engineers to put this into production so that their work can become part of a larger system. Our platform essentially takes all of that away so that quants and data scientists can do their work, deploy it into a platform that can automatically take the results of their work and ingest it into other systems. So our tech stack is pretty complete. So we start with nodes. Then on top of that, we build ETLs. So we extract all the data from the nodes, we index it, decode it. We also provide custom data sets. On top of that, we have what we call the CMF, the Credmark Model Framework, which is what we're going to focus on today. And then the output of the CMF, i.e. models, get deployed into a managed execution environment, and those are ultimately available via API. So now I'm going to hand it over to Kunlun, who will tell you, will give you, I think, a pretty thorough introduction to the CMF. And later we'll be running workshops where we will discuss and show you how to build different kinds of models. But today is really an introduction. Kunlun, over to you.
All right. Thank you. Thank you, Paul. So GM, dear fellow data analyst, engineers, and data scientists under from MetricsDAO. So I'm Kunlun from Credmark. I'm here to introduce to you the CMF, the framework that is based on Python, and we have been building it for the last 2 over years. So save your question and we will come to you later. So let's walk through the basics about CMF. So we will be doing 2 demos. Mainly we leverage the GitHub code space, which is a VS Code on the web, and to as a basis to or an environment to demo CMF, which is a Python-based modeling framework, and touch on various components and things and tasks we can do inside CMF. And then we'll proceed to the second demo, writing or show you some of the codes from CMF models. And it's mainly on NFT minting. So let me walk to you first about CMF, which is short for Credmark Modeling Framework, is built around
Excuse me, Kunlun, do I
Web3.
need to move to another slide?
Oh,
Or
sure,
can you,
sure, sure.
can you
Yes,
take
please.
control of these slides?
Okay,
Or
yeah.
can you control them?
Maybe let me just
Apologies, everyone.
take
This is our
over.
first time on this platform.
Yeah. So I saw that I'm on the sharing. Maybe Paul, you can take down your sharing, and then
Let's
my
see if
existing
I
sharing will be
can.
take over. Yeah.
Okay.
Okay.
Have you taken over? Good.
Yeah.
Excellent.
So I was on this slide only. So we will be doing majorly 2 demos. So first of all, CMF is our modeling framework that's built around Web3.Python, and we can use it in many ways. I wrote an article in this link called "A Million Ways to Use the CMF." A million could be a bit exaggeration, but definitely there are more than one way to use the CMF in Jupyter Notebook, in a console, and also in command lines. So today we are going to use the code space as an environment to demonstrate CMF. So which can be launched from our code repo, which is open source and shared on this GitHub link, and go to code, click the tab code spaces, and then you can add a new code spaces. And GitHub has been generously offered these 3 hours for code spaces to be used every month
And
for every
Kunlun,
user.
can people in the audience just follow along and actually open up their own
Definitely.
version?
Yeah.
Great, cool.
So the other way is to use CMF locally. You can use these sample commands to clone our Git repository and create a virtual environment and then do the installation. So these 4 lines should be able to give you a good start. So as a very high level outline first, that these are the things we can do in CMF. We have created Python objects for Web3. So we have objects like block number, address, contract, token. And these are Python objects that behind it is Web3, and it just automatically downloads the ABI so that the functions and events can be called, and the historical events log also can be fetched. And it's a highly integrated part inside CMF that become many of the building blocks for the models. And we can call smart contract in Web3. And we have the ledger data, which is essentially the blockchain ETL data that's digested from the archive node all the way from Genesis block. So we have a list of tokens, list of contracts, list of transactions, and list of token transfers. And these can be curated. And the ways can be curated will be shown later. And we have a large collection of existing CMF models that's being built upon from the Python objects, the Web3 smart contract calling, and also the ledger data. And these have become incremental building blocks that we hope that the existing ones will be inspire the new modelers to build the new models, and then the new models will inspire other modelers to build more and more, and so that we have an ecosystem of models. So the first thing demo I want to do is to showcase you how to use CMF in the Jupyter notebook. So the notebook is a part of our code repository under the Credmark modeling models.py. So let me switch over to GitHub. So this is the link, GitHub/Credmark models py for Python. And I will start my existing code spaces that are already being created. It takes a while to initialize, but it should be very fast. And adjust the font size so that it looks great. Yeah. So the demo notebook exists under the subfolder called notebook, and it's called demo.ipynb. So to use the CMF inside Jupyter Notebook, of course, this environment has already been installed with the Python modules that essentially follows the 4 lines that I show on the slides. And after we have installed the CMF, and these are the lines that to initialize and load the modules from CMF. And the first one is essentially just to create a CMF environment. And the second one is already importing the Python objects from the CMF. And we have a dictionary that holds the configuration variables and to initialize the CMF environment. And the better name we call it is called a context. So a context in the CMF means a Web3 environment that's referenced to a block number and also to a chain. So we also support other chains other than the mainnet, and as long as we have you have specified a chain ID here. So now we have stick to the chain ID 1 for the mainnet and also a block number 17 million. So if you remove this line, you will be default to used to the latest block. But after we have created the context and the CMF, the block number will be fixed. So running this block, this cell in Jupyter will help us to create a context in CMF. And once that's done, let's proceed to the second section. So use the Python objects. So the block number is the simple object that interacts with the Web3, and so that it fetches the block number and also its timestamp. And so the first line is just to create a block number object according to the block number ID that has been supplied. And after we have created, we can actually use it like a Python object that it has a property called timestamp datetime. And then you can further format it using the Python datetime object method called string from time. That will give us a nicely formatted time. And we have other utilities to get a block number from the Y, the year, the month, the date. And then once this object has been created, we can also look up for its timestamp. So this is just a simple object, but behind it, we have built-in integrated to the Web3 and also our ETL data so that we are able to look up a block number from a certain time. So moving on, I'm coming to the more complicated object like token. So the token can be initialized with address or a limited set of symbols. So we have a list of around 1 to 200 symbols that's already been preloaded. But given that we have millions of tokens and we have millions of probably fake tokens and spam tokens, we're not able to just specify USDC and to load them all, right? So we only provide a curated list of tokens that's being included in the framework and we often use so that we can just call them with the symbol instead of an address. So the token object can be initialized with the symbol that's being included in the framework. And then the token object can be called with various properties like a Python object. So to get the address of the USDC, which is token USDC.address. And this address is actually an address object so that the address object has a method called checksum, and then you will return the checksum object address of the plain address, lowercase address, that's being ready to be sent to any of the Web3 calls to be processed by the smart contract. So what's power behind is the address object. So that's a simple case to just create the token object. And what's more, the token is actually a derived case of contract object. So the contract object is also be able to initialize with an address. And after we create the contract object, we can call its functions, and it will be exactly as what you see from Etherscan, and you can put in different parameters, different input to get the output. So here I'm calling the Uniswap v3 factory contract to fetch a pool that's between WES and USDC with 0.3% of fees. And this is the address of the pool that's being returned by the Uniswap v3 factory. And we have another example here, which is for the token object. And many of the ERC20 attributes like symbol and decimals are already built in. And apart from that, this token has its own specialized method called rate. And this can also be called from the functions. So these are the first part with this Python object for the Web3. And this will be an easy way for any of the data analysts to interact with smart contract under the CMF. So the part two, once we have the contracts, for example, this address of the pool, and how can we look up for data? So we have the ETL data that's from the blockchain. The blockchain data can be accessed from this object under the context called ledger. So the ledger will contain these tables like block, contract, log, receipt, token, token balance, token transfer, trace, and transaction. And the list of tables can be accessed by the dot tables function. So let's get what is inside the token transfer table. So the token transfer table can be looked up from ledger.table past the token transfer name and plus the dot columns. And these will be returned as the list of columns that's under the token transfer ledger table. So we have created a similar syntax to SQL, but rather you write it in Python. With the token transfer table as a q.select that highly resembles the SQL select statement with these columns, and where the block number is between the recent 5 block number from the current block and then the last 2 data frame will convert the result into the pandas data frame that every data scientist working with Python should be very familiar with. And this is the result that will be returned. So for the last 5 blocks, or maybe 6 blocks, that there are already 562 token transfer events happening in these blocks. And the next example is a bit more complicated because we use join. So we join the token transfer table with the token table because we have all these lists of token transfer transactions, and it all returns different values, and that's in each token's decimal points. So by joining with the token table, we can fetch the decimal number for each token and use that to normalize the value so that we can be all to the unit of 1. And this query will be run and we can sort. There will be more SQL-like arguments has been added, like group by, like order by, so that we can order everything by the sum of the values. And this will be the result. And don't forget the last 2 data frame that will convert all the data to a data frame in pandas and ready for further manipulation. After getting all the data, and it's time to package everything into what we call a Credmark or CMF models. So the CMF model, we have a list of models that can be accessed from here, called context models. And we use dir so that it lists all the models. So let me do a count first. That's 280 so far we have created in this model repository. So you can see that all the models has been has a normalized name. First part is always the protocol name and followed by what does the model does. And you will find many of them under the context models. So so many of quite a bit, not many, but quite a large collection of models has been built around getting a price for a token. So there's this model called price.sex that is to fetch the prices of a token from Chainlink oracles. So notice that first of all, we created a CRV token that's initialized from an address. So the same way can also be done with the symbol name, because CIV curve token is inside our created list of tokens. So once we have created this object, we can pass to the model as model parameter, and then the model actually interprets the token object and gets its address and look it up in Chainlink registry and fetches its prices. And we have more complicated models like Uniswap v3 ID. So this is to fetch a position, LP position on Uniswap v3 under the ID and also from a block number. So the position will be fetched from the Uniswap v3 NFT manager, and the detailed information at how many fees has been collected and accumulated on this position will be calculated at a specific block that's also being included in the result. So as of this block number, that this position has been out of range. And we have many more models that we can show, but I think in regards of time and consideration of time today, I will just stop here by going to the next section. So we have models on RV token, and we have also models on Uniswap v2 protocols. And IPO, the interest rate swap protocols that's being advocated by many of the quants. So this is all inside the demo IPython notebook. And we definitely has been stuffing a lot of information here so that you would get to know many of our details of our CMF. And I hope that you will find it useful. So with that, let me come to the second part. The second demo is to write a CMF model. So the CMF model can be structured in such a way, like 4 parts. So it is in a normal Python source file. First of all, we include the relevant modules, and you will see very similar to when we use the Jupyter. The Jupyter, we are importing the IPython create CMF. Here, if we want to create a CMF model, we import the Credmark CMF.model, and from that module, we import model object. And then we import a few types that we are going to use. And also, we include certain data transfer object that is used to JSON serialization and deserializing our data. And the second, we use our describe function with a list of metadata. The metadata, we include the important details about the model that to describe the name of the model that should be unique among all the models, and also the version, the display name, and description that's relevant to what does the model does, and give it more information about to the user of the model. And also the input and output of what the model does. And the input and output, it can be specified as DTO, the data transfer object, so that the data can be validated before enter the model. And also when the data being produced by the model, it will also be validated first and then send it to the response. So this is the metadata that described what the model does and also the input and output. The third one is the run function that serves the main body of the model. The model will be run with a chain ID and a block number. And we have built in our frameworks that the model that's being run on a block number can only access data from the current and the data from the previous block, so that we will keep the model that's only deterministic to the time that has been run, and it can only look to the back and not to the future, so that we keep every model run as only the result will be catchable, and also the result will be fixed, so that we can always reproduce the model results. So the main body of the model need to be written in such a way that it can create object, the Python object to access the Web3 data, and I can also call other models, and then it creates a return data that's ready to be JSONified. So this is a simple model that looks up for the USDC price, looks up for RV price 1 day earlier, and then return all these results in a simple dictionary. So the dictionary will be a detail object that actually doesn't need any of the validation. So that's just for demo, but we have more in production ready model that to be shown. So that's also can be found in our repository. So here I did a demo for a data analysis board for the Pulley NFT. The original version of this analysis board is presented as a tutorial for Dune analytics. So I have replicated all the analytics has been done in CMF as it was, and also currently available in Dune, so that we can have a comparison between how CMF works and how Dune works. So there are around 6 and 7 or 8 queries. So for each query that has been listed in this notebook, and we can see its result. So how many funds has been raised by selling the Pulley NFT? So it has been totally around 1,000. And the model code is inside this model. And how many funds has been raised in USD? And this has been coded in this model. Contribute, Pulley fund raise USD and count. Total supporters 7,000, and close to 2 million has been raised. And what is the leaderboard has been coded in this model. And then lastly, the supply and the NFT minted over time. Since it has been launched, within less than 2 months' time, it's already been sold out. So this is the dashboard that's been built on top of all the models. And the model's source code is actually being found here, the Pulley _ NFT. So the first model, Pulley fundraising. That means how many of the total number of funds has been raised from this NFT. This is the query on Dune Analytics. So 2, which is the address of the NFT, and equals to either one of these 3 addresses. And then do a sum. So that's a SQL query. So one thing we have noticed that inside the SQL, you have to repeat the addresses and copy them around. Since we're in Python, why not? We create a base class that hosted all these NFT addresses as a constant inside the class. And then our class will be inherit from this base class and together with the CMF model class, so that all these addresses will be available to every Python class instead of copying to every query. So inside our CMF model, you will see this part, which is query the ledger data, has a highly resemblance to the Dune analytics or any of the SQL that can be fired to the blockchain data. And what is good about it is that it always return a pandas data frame. So we can have a case to catch if we are really doing this analysis at the start of the fundraising. And probably we haven't got any funds raised. And we can check whether the return data frame is empty or not, and then return a simple result is still being 0. And over time, when the fund starts, and then we can, the model will have accumulate more data, and then we can return a non-zero number result from the fundraise. So this query to the ledger data has been on the core of this model about simply fetching the number of ETH has been raised from the NFT sale. So let's get it to the next level. So the next level will be, how can we get how many US dollar values from these ETH has been collected? So we need to collect the same ETH, but we need to accumulate onto every block ranges, or to be very granular, we can calculate onto every block. And on the other side, we need to collect all the prices on every block or every block range. So here, the first part, since we are no longer doing the sum, so we need to get every line of the transaction out. So currently we have a maximum number of 5,000 number of rows to be returned in each run of the ledger model run. So that's why I'm running a while loop here. Only when it returns less than 5,000, that means we have fully fetched the result. So this is the first part, to fetch all the transactions. Where is the second part? To fetch the prices on every block, or let's do a bit coarse granular, that means in every block ranges. So we have a model called price.dexdb interval. So the interval means that it's able to get a start time stamp and end time stamp, and with interval has been specified. So here I specify a day. So 80,400 seconds is a day's number of seconds. And then I will fetch all the West prices during this start time and end time with the interval has been specified. And the model returns is a JSON list, and we convert it to a data frame. So the two data frame can happily join all the transaction details and also the prices, and on to the block timestamp, so that the number of ETH has been collected from the selling of the NFT and can be joined with the price of the ETH at that block range. And these two will be just multiplied to each other, so that we have the total dollar value of the from the fundraising of these has been collected. And then we can return all the results in a dictionary. So this will be our CMF way to write a model that contains 2 time series. And instead of writing everything in a huge block of SQL, we can fetch the data separately using different ways, using the ledger data or using any data sources. And not to forget that the DEXDB is our flagship price database from the decentralized exchanges like Uniswap, like Curve, like SushiSwap. And we also have other data sources like Chainlink, like Oracles. So if you want to have a choice of different data sources for prices, instead of fetching price DEXDB, you can fetch from Chainlink with the time interval. That has also been supported from our framework. So for different parts of the data, you can specify and have your own choices and use Python tools like pandas, like data frame to manipulate, to join, to merge. And this is the beauty of the CMF. So I think that will summarize what I want to present today about CMF, and hand over to Paul.
Okay, that was amazing. I hope it wasn't too overwhelming. So I'm just going to very quickly wrap it up, and then we'll answer any questions that anybody has. Let's see where we are in the slides. Kunlun, I think you're controlling them. Can you advance? Oh, maybe not.
Yeah, I just released my control.
Okay, all right. We're getting there. Okay, so just quickly to wrap it up. So to summarize everything that that Kunlun talked about, how we're different from a lot of data and analytics platforms. First of all, the one important thing to remember is that we combine both the historical and the current state of the blockchain, and we allow you to compute on the totality of that data from within any model. And of course, we let you bring in any Python models or modules, excuse me, that that you want to work with. And of course, those Python models can call external data sources. So, for instance, you wanted to go get FX rates from another provider, no problem whatsoever. And the other thing that we didn't talk about at all today is or that I mentioned earlier is the full stack nature of the platform. So once these models are written, you can make a pull request. The model will be then reviewed and added to the platform, and then accessible via API by anyone who happens to have an API key. So very quickly, the CMF is free and open source, as are the models that are deployed on it. We are talking to customers who want private instances of the CMF, so that is absolutely possible. But it does require quite a bit of hardware replication, so it's not the cheapest option. On the other hand, if people are developing proprietary models for their business, it may make sense. What is the way we actually monetize all of this is via APIs and data sales. So there is an API that allows you to call any model in its raw form. And then we take our most popular models and we curate them into REST APIs that would be very familiar to any Web2 developer. So for example, we have a token API, which will provide information about tokens. It's the kind of information that you would expect, pricing, decimals, symbols, etc. And we are close to releasing a portfolio API, which will allow you to add information about portfolios or addresses, and then request information about that data. And then we are also working on a few others that will be announced down the road. As Kunlun, I don't think he said this explicitly, but implicitly he talked about the price database and the price models. Now, the price model we have run across every single block for the tokens that whose price we want to cache, and then that produces a data series that we are then able to sell. We can do that with any model that's built. So the implication is if you want a data series, an easy way to produce it is to build a model and then run it across a data series, and then we can take all those results, put them in a database, which can then be available for sale. So those are the ways we monetize the work. As Kunlun mentioned, any model can call any other model. So really, very, very few people start from scratch. They tend to start with a model and then build on top of it, or build a derivative, or use a model, then combine lots of others. That's what we had for you today. We're very happy to take any questions you might have.
Thank you so much, Paul and Colin, for the excellent and insightful presentation on Credmark. If you do have any questions, drop them in the chat. There is one question by Amir, who's asking if there is any module or layer in your product which uses AI.
There is not right now, but there certainly could be.
Okay. Also wondering if anyone has any questions later on, something pops up, where would be a good place to connect with you guys or with Credmark and your community?
Aha! So the best place is our Discord, and you can see that the address seems to be occluded by the by our videos. But if you go to our website, credmark.com, on the lower left of the homepage, you will find a link to our Discord server. So you click on that link, that's an invite. You can join our server. You can find both Kunlun and I there. There you go. Thanks very much. And anyone else who happens to be around. You can also find us on Twitter. That's also available through our website. Thank you very much, Credmark HQ. And of course, all of us have individual Twitter handles. Mine happens to be PR Murphy. Kunlun's is slightly more complicated because it has nothing to do with his name. It's Leaf Young. And of course, we're available by email as well. And it's our first name at credmark.com.
Awesome. So do ensure to connect with Credmark if you have any questions. And this event will be followed by a workshop. So we'll get as well chances to get a bit more practical with using the tooling. And we will be having the workshop on the 20th of June. So it's just above a month. So I will also share the link here in the chat for anyone who might be interested in registering to the workshop.
Thank you very much for including that.
Right. So if there's no more questions, then we can slowly wrap it up. So before we do it, is there anything that you'd like to share with us as the last words?
I just want to thank MetricsDAO for putting the series together. I've seen other people's presentations. I found them incredibly useful. So I appreciate you guys doing this work and getting the word out there and helping the community access and discover tools.
Yeah, I feel the same that we need a variety of tools, and more important, we need a variety of intelligence and contribution and the community for all the Web3 data works.
Thank you so much for your words, and thank you so much for your excellent presentation. Um, and we'll see you then in in the workshop. And thank you also everyone for attending
Fantastic.
today. And have a good day or evening. Bye bye.
Okay, goodbye. Thank you.